Hello, welcome to another drive-by code session. We're gonna continue on with the implementation of the JSON parser. This time we're going to do a proper implementation of parsing quoted strings. And currently we do have a version that works just in an incomplete way. So in terms of parsing strings. So this is our definition for really at the present, the definition for how we parse strings are these three rules. So we got string literals. This is a literal double quote, and that's a literal double quote, and between that is a bunch of characters. So you might imagine a string like this. It's got a double quote literal on the left and to start the string, and at the end to close off the string. In the middle, there's any number of arbitrary characters. What is the definition of characters? Well, a character is characters is one or more characters essentially, and it does this by using this recursion trick that we talked about. If you're not familiar with the recursion trick, you can look at that in more detail in the by going back and watching the first episodes. But basically what this is saying is a character is either one character or a character followed by more characters, which kind of recurses back to itself. And this trick allows you to have a string of characters, basically. And then finally, what is the definition of a character? This guy here, that is a character class matcher that says this caret has a special meaning that means not. So this is matching anything that is not the double quote. This is an escape slash for the double quote character. So basically this whole thing means anything that is not the double quote character. So but we actually need to be able to allow the double quote character, don't we? Because we can potentially have strings which have double quotes in them. And in JavaScript, how do you do that? Well, in JavaScript, you can use a single quotes to delimit the string, but that's actually not allowed in the JSON specification. So this is allowed in JavaScript, but not JSON. In JSON, the only way to do double quotes is if you escape it with a slash, like that. And then you want to do another one, you need to do another slash. And it turns out there's more than just the double quotes that can be escaped, and all of that is actually described here in the JSON.org, which is the official website for JSON. And the official website for JSON actually has the entire grammar of JSON listed out on the right hand side here. And you can actually look at exactly how the string is specified. And as you can see, it's in the grammar, and the grammar format is not that far off from the grammar format that we're working with in Nearly. So the plan for this episode is simply to sort of rewrite these grammar for matching the strings in our parser here, over here. So that's what we're gonna do. Again, WhiteKit did all of the code. I'm just replaying what he did and explaining it. WhiteKit is sort of gonna take these rules line by line almost and translate it into this Nearly's syntax here. But essentially what this guy is saying is a character can be anything. This guy, this is a character range. It's done in a different format, but essentially that is meant to say any character at all. My handwriting. Any character at all. And this is minus the double quote or the single slash. Why do we know why we minus the double quote, but why do we minus the single slash? There's a good reason for that is because we want to match the single slash in the second rule, in a separate rule, which in the second rule, the single slash starts this escape sequence, and we don't want the single slash to be matched by this first rule, which will potentially cause the single slash to escape the second rule. So when we do see the single slash, we want to for sure go through the second rule. Yeah, so that's the plan. So let's try this. So first, we're gonna have a single character be any character which is not. That's what this character stands for, not. Anything that is not, anything that is not a single double quote, this is the double quote, and it needs to be escaped. That escape is for nearly itself, and then the second one is escape of the slash itself. So this guy is a single slash, and this guy is a single double quote. So this character class gives us the same thing. That gives us basically any character that is not the double quote or the slash. So that's what a character is, or a character could be a single slash. Again, that single slash needs to be escaped for the sake of nearly. And then something called the escape, which will be defined thus, and we'll define escape as either a single double quote. Again, it needs to be escaped, in which case we will return a JavaScript representation of a double quote. We're gonna sort of translate on the fly here, and this is a one literal slash, which it needs to be escaped by itself, and then in JavaScript we return the same thing, one literal slash, which also needs to be escaped by itself in JavaScript as well. And then we got a forward slash. So you could potentially escape the forward slash with a backslash, but that's actually optional. So you can write it like this as well. And then we got a bunch of white space characters. So slash B is backspace, and then we got slash F is what is that? I forgot what F is, but N obviously is new line, and R is the character return, and T is the tab. There's the U, which allows you to specify a character code in hexadecimal numbers, but let's do that a little bit later because that gets more complicated. We have to deal with hexadecimal numbers, etc. Okay, now we're gonna try to test this out. So can we make a have a quote? So this is a string which starts with a double quote and ends with a double quote, with the content of the string being a single double quote, which is escaped by a slash. And the reason this needs to be a double slash instead of single is because we need JavaScript, because this is a JavaScript file. We need this JavaScript file to interpret this guy as a literal single slash. So we need to escape it with itself. This is gonna get complicated, so we're gonna actually externalize this input in a bit. But right now, let's see what happens here. Okay, we'll have the terminal. I'll switch to the replay terminal to see what YKit did here. Okay. So now he's gonna run this parser after having already regenerated the parser. That doesn't look right, and I think he has a bug in there because he's forgot to transform the data that's parsed by this rule into, or just provide a transformer. So he's gonna do that. So this transform basically takes this array of information. So again, think of this as an array, and takes, this is the 0th one, this is the first one. It takes the first one. So whatever escape is, which would have come from one of these guys, one of these transformers would have returned a character back, and that's gonna go into data index 1. Yeah, so basically whatever the escape returned, this character will be that. So we're gonna need to, I keep forgetting and typing in there. So run the generate parser again and run it, and now we get a hello that has literal double quotes in it, and that's what we want. Now let's externalize this JSON code so that we can write just one slash instead of having to write 2 slashes in there. So externalize, and now in the parse.js we're gonna have to read in the file, which for that we like to use a library called mz. Highly recommend this for any kind of anytime you're writing Node.js programs, really, and having to deal with asynchronous stuff. So you require the file system from mz instead of the normal Node.js file system, and now you can use async await syntax, which I love. By the way, we also made some videos about async await, so you're welcome to check those out as well. So this is how you read in a file. The result, because of mz, the result is a promise which we can await on, the result of which is a buffer object, which we can do a toString in order to get the string content. And now this is the input. We're gonna feed that input into the parser and run parse again, and now we get the same result, only now the input comes from this input.json file. Okay, now let's change the input a little bit, put a new line character in there using this /n, and also let's just display the result, pick the result out of the parser. Oh, there's a typo here. Okay. And then we see that now running the parser gets us the string with a valid new line character, because we see the line separation now between the hello and the world. You can also see that escaping of the double quote character now works. Cool. Obviously we should be able to do arrays still, and we can see that we can do that as well. And okay. And you can do taps as well, so that proves we can do the escapes. Now let's go back and do hexadecimal numbers, which on the JSON.org webpage, it is written in this way. So if you're gonna do an escape, so this actually looks like this. It looks like if you have a string and you write the escape slash and then a u and then some number, say 0065. Actually, that's not a great example. These are digits. These are hex digits, and there are gonna be 4 of them. So 1, 2, 3, 4. Each one is a hex digit. What's a hex digit? Well, a hex digit can be a digit, a normal digit, a decimal digit, or because it's a hexadecimal number, it can also be a letter between A and F. So yeah, and these 4 digits will give you a character code which you can use. For example, you can do this, and you get 1 character that looks like a Y with 2 dots above it. I don't know what that means exactly, but if you do something in a lower range like that, actually got a C for the hexadecimal 0043. So that is what the JavaScript language supports, and also the JSON language supports. So we gotta support that. Okay, so let's write those rules in. So yeah, we're gonna have if you're gonna have an escape slash and then a u, the parser is gonna expect 4 hexadecimal digits. What's a hexadecimal digit? It's either a digit, a normal digit, decimal digit, or one of the a letter between A and F. And for a digit, let's just return, well, we're gonna actually convert it to a number, and then over here we do a calculation to convert it to a decimal number here. But this is how it works. So we're gonna say, we're actually gonna take, whether it's lowercase or uppercase, we're gonna lowercase it first to put it in our switch statement. And we're gonna say if it's an A, that's gonna be the 10. If it's a B, it's 11, and so forth, all the way up to F, which is 15. So now, oh, actually there's a problem here. The digit, I think he's gonna fix it in just a moment there. So if it's like a decimal digit, we're just gonna use the number conversion function to take this digit and convert it to a number without having to write this switch statement. Now we need to convert this. So let's say there's 4 digits basically at this point. Let's say it's 1111. There's 4 digits, but this one represents 1, but this one actually represents 16. This one actually represents 16 times 16. What is that? 256. Oh, you can tell I'm not a real computer scientist. I can't just do that in my head. And that one actually stands for 16 times 16 times 16, which is 4096. So basically, in order to convert this, I want to multiply this guy by 16, and then add this guy, and then put them together and multiply that by 16, and then put that together, and then multiply that by 16, and then finally add it to that guy. I hope that made sense. Now let's do it in the code. So if you look at this match as an array like that, then the U is index 0, and then this is 1, 2, 3, 4, right? So we're gonna take this digit here by the 1 and put it in here, multiply it by 16, and then plus this second one, and then add them together, and then multiply the result of that, all of that, by 16. Now incorporate the third digit, add them together, and then add them all together again and multiply by 16, and then finally add the fourth digit, and then we have the character code. And after we have the character code, we're going to use this method from the string constructor, string from character code, and give it the code. That should give us a character. Let's give that a try. Generate the parser again. There's an error, probably syntax error. Oh, I think it's this one. We have an extra arrow. That should be an or sign. Okay. Oops. Looks like that was fixed. And now we're gonna try to, oh, no, that's not right. Change that to a U. And now that gives us E. If we do 0041 in hexadecimal, that gives us a capital A. Let me try it by myself because the replay term is sort of giving me messy output. So yeah, 0041 gives us an A, and if you go to Google for the ASCII table, you'll know what to expect for what. So this table gives us everything from code 0 to code 127. Although this 127 is in decimal numbers, what you want to look at is the column in hexadecimal numbers. That's HX here, and we can see that with the 41 for hexadecimal, that gives us a character A. So if we wanted an lowercase n, then the hexadecimal for that is 6E. Let's give that a try. Yeah, lowercase n. So very cool. He's trying a few different characters. Let's see what he come up. What the heck is that? I have no idea what that symbol is. That looks really weird. I'm gonna conclude this video around here. If you're watching, if you are a viewer of our channel, Whitekid and I'd like for you to give us some feedback. Put a comment under this video. We'll love to hear from you. If you're interested in actually learning how to build a parser using Nearley.js or any other tool, if you want to try something different, then I strongly recommend that you actually get some hands-on experience and do it on your own. If you want to follow along with this video series and build a JSON parser, you can do that. I kind of intentionally left off not building the parser for the object literal syntax. So that could be a take-home exercise for you, the viewer, but you could build a parser for other languages, other simpler languages too, such as CSS or HTML. Next in this series, we're going to start getting into something that requires some computation. We'll do a parser for simple math equations. So thank you for watching and hope to see you in the future.